Hi, everyone. My name is Avery. I'm the CA for CS111A, and some of my students have requested that I do these project walkthrough videos. So I'll be making these videos for Project 3 onwards. And every week I'll make them around Thursday, and then I'll try to upload them by the end of Thursday, maybe early Friday. So hopefully you'll be able to watch these videos and get started over the weekend. In these videos, I'll usually start by pointing out what in the section handouts are important. So last week was section 2. This week you all went to section 3. So I'll quickly just go over what might be important in this on the section handouts and point to what parts of the problem you might be relevant to the section handout. As well, I'll also, if ever any lecture concepts are important, I'll point them out as well. All right. Yeah. And then what I hopefully will be able to do is I'll be walking through the starter code. So do I have the starter code here? I'll actually download the starter code, and then I'll be walking through that starter code, walking through the different functions. Just if there's any anything confusing about the syntax that is there, I'll make sure to point it out. And I'll also walk through the test harness and give you some suggestions about how you might test your code. All right, so let's quickly let's talk about this problem. This project is about synchronization. So you'll be using mutexes and condition variables. These are important because in the past few weeks you learned about processes and threads. But when you ran these processes and threads, you mostly just ran them independently. Other than yielding and context switching, these threads don't really depend on each other. So now we're going to deal with problems where when one thread is running, sometimes it has to wait for another thread to complete its task before it is able to continue, right? And so that is these two problems that we'll be doing. The first one is called Caltrain automation, and the scenario goes like this. You have a bunch of passengers and you have trains. These passengers will start by entering the station, and then once they get onto the platform, they will call wait for train. Okay. Now, what's important about these functions is when this passenger calls wait for train, the wait for train will not return until the passenger is done waiting for the train. So while the passenger is waiting, that function, that thread that the passenger is running on is going to block. Okay, so it's just ideally here you want it to go to sleep. Now, there will be multiple passengers, so there will be many threads, and as these threads, as the passengers enter your station and are waiting for the train, they call wait for train and then they block. Okay, so you have a bunch of these threads that are just blocked. Okay, so wait for train, partway in the function, it will block and will not return until another thread that represents the train, until that train arrives at the station, opens its doors, and then it will call this function called load train. All right, and then when load train is called, it tells you how many seats are available. And when that happens, now your passengers who are waiting, they're blocked right now, they're waiting. They should now be told, hey, the train is here. You can now start boarding. Okay. Although you do have to be careful here because there is a limit to how many seats are available. So perhaps 50 seats are available, but you have 100 passengers. In that case, if 100 passengers are waiting, but only 50 seats are available, then only 50 of these passengers should start boarding. Okay, so you'll need a way to keep track of how many passengers are waiting, how many seats are available, and who is able to board. Okay, but yeah, once you call load train, the passengers should then wake up from. They're currently still blocked inside this function, but they should now wake up, see that the train is here, and then some number of them should start boarding. Okay. Now, as these passengers are boarding, the thread that is representing the train, that thread is currently in the load train function, and it needs to block. All right. So previously it was wait for a train. The thread calling wait for a train that was blocked. Now the thread that was calling load train, now that thread blocks. So this thread now waits while all the passenger threads are now boarding your train. Okay, and then what will happen is there's this function. So this is written, it says once a passenger is seated, it will call the method. It is a little ambiguous here. Your passenger thread really never calls seated. So there's actually like the test harness is the one who actually calls seated. So the passenger threads, like you will never actually call seated. You're implementing seated. Some other thread who is monitoring the situation, when it sees a passenger has been seated, it will call seated for you. Okay, so seated basically says, oh, every time seated is called once, you know that one of the passengers who was boarding, now they have been seated on the train. Okay, so yeah, you can imagine how this might be useful, right? Every time seated is called, you need to remember, okay, so someone has been seated, which means my number of passengers who are boarding has decreased by 1, right? And then you need to keep waiting. Seated will be called many, many times. You need to keep, this train needs to keep waiting until seated has been called enough times so that you know that all the passengers who you just told to board, until all of them have been seated. Okay, then this load train function should then wake up again and depart. Okay, now depart, you don't have to do anything new. Just wake up when everyone has been seated and return from the function. Okay, so yeah, what's important is these two functions, they will block and they will wait until something has happened. For the passengers, they have to wait until the train has arrived, then they can start going onto the train. Although let's see, until the train is stationed and there's enough train. Yeah, so this function has to keep waiting until the train is in the station and they are told to board. While the train function needs to wait until everyone who was told to board has boarded. Okay, and that you know that through the seated function. The seated function is not supposed to block. It's just supposed to just make sure that the train knows that one more person has boarded. All right, so that is the Caltrain automation problem. A couple of things you want to think about. So think about who is waiting for what in this scenario, right? You have the passengers who are waiting for the train to arrive. So that is one instance where where one thread is waiting on another thread. And then you have another scenario where this train thread is waiting for seated to be called in. Okay, so through that, you should now think about, okay, how many condition variables do I want? And when do I wait? When should a thread call wait on these condition variables? And when should a thread call either notify one or notify all to wake the thread that was waiting? All right. So yeah, now that we've gotten the problem scenario over, I hope that explanation, the explanation here is pretty good, but I hope that explanation helps you clarify anything else confusing. I think the most important part here is that remember when the train arrives, not all the passengers will be boarding. There will be some passengers who still need to wait because there's not enough seats for them. Okay, yeah. All right, so yeah, there's some additional information here, but what I think is most helpful is if I go through the test harness, and then there are a lot of test cases there. So let's go through some of those test cases, and then we can actually just make sense of those test cases, make sure that we understand the problem. So let's go to so I'm using VS Code. Let's download the starter code first. So starter code, you download it in the same manner as the first two projects. You copy paste the skit clone link into your file, and you should get the starter code. There's a couple files in the starter code. The files that you'll be working on is called Caltrain. Later, there's a problem called party. And inside the Caltrain file, you can see that, move this to the side. You can see that there are, in this file, both the class declaration here and the implementation of the class is in the same file. Okay, yeah, I know in the thread class, you had a separate thread.hh and a thread.cc, but this is a small problem, so everything's just gonna be put into one single class. So yeah, this is the class over here, and then here is the class declaration here is the implementation. Inside the starter code, you can see the 3 functions you have to implement. These are the 3 functions here. You don't have to modify these public interfaces at all. And you also have this constructor. Okay, now this constructor, you will notice this syntax over here. This is called the member initializer list. And it was covered in section 2 on the handout as well. And you also used it for assignment 2. So double check that. The member initializer list is important here. And a big reason is that mutexes, and when you declare condition variables later, mutexes and condition variables cannot be copied. So you'd either have to move them or to construct them directly into these members. So yeah, by what the member initializer list does is it directly calls the constructor to construct these member variables. It's as opposed to what you might have seen in other classes where you write something like mutex is equal to like a new mutex, right? If you were to write this actually does member assignment rather than just as a constructor, so you might get issues. So yeah, just the TLDR is use the member initializer list. That will save you from a lot of errors. Okay, so yeah, you now see these 3 functions. You also see that we've already declared a mutex for you. We're using the monitor style here, which means you only have a single mutex, and this mutex needs to protect all the other member variables, these state variables inside of your station class. So inside of your station class, you might want to, inside of your station class, you might want to declare some, let's see. So everything's under public. I guess for this question, it doesn't matter if you declare them under public or private, but yeah, you would declare your other variables down here. For example, if I wanted to declare, I don't know, num passengers. I'm not saying you definitely want a num passengers variable, but if you wanted to declare one, you would just declare them down here. And this mutex that we gave for you, this mutex should protect all of the member variables that you're declaring in this station. Okay, so yeah, remember when you have multiple threads and if they all are trying to modify a shared variable, you might result in some inconsistent state where it's what we call a race condition, right? Both try to modify the variable at the same time and you don't know who gets there first. To protect against that, we use a mutex that we can lock these critical regions, and this single mutex is supposed to protect all of the variables. Okay, now you might argue, oh, if I create more mutexes and I am more fine-grained in my locking, isn't that better? Well, depends. Usually not. Usually it doesn't get any better. And just for simplicity, it's just much easier to have a single mutex. Okay, so we gave you a single mutex. Don't declare any more mutexes. What you do need to declare is you need to declare condition variables, right? Every time you have one thread who needs to wait for another thread, like for example, the wait for train function will probably need to wait until a train arrives. And then in load train, when the train actually arrives, this function needs to signal to all the passengers that, hey, the train has arrived. So just as an example, you probably need a condition variable that is shared between the implementations in these 2 functions. So you probably need some condition variable here. If you declare the condition variable here, all 3 of these functions will have access to that condition variable. Okay, now you might need more condition variables, right? That's not the only place where one thread is waiting for another thread. And you just declare all of these condition variables down here. You can only declare one mutex, but you can declare as many mutexes as you want. Although, yeah, just declare as many as you need. Yeah, so that's it mostly for the starter code. There's not, the starter code is much simpler than the starter code in project 2. Yeah, for this problem, I don't believe you need any data structures because, yeah, you don't really need to store anything. The only things you need to remember are how many passengers are boarding, how many passengers are waiting, how many have been seated. So yeah, you don't need to add any extra include statements. Sometimes it might be helpful. I personally really like print statements. I'm not a fan of GDB, but yeah, some students have asked me, how do you print? I'm getting errors when I try to do cout. Yeah, so cout is in this class called IOStream. Okay, so if you need to do any couts, you just write this, and then you would be able to cout every time something is being called. Okay, let's walk through the test harness. So this test harness, I think is much easier to comprehend than the test harness for project 2. Project 2 just had a lot of thread creation and lambdas. This one I think is more straightforward to read. Okay, so it's a long file, but I'll go over the important parts of this file. Nothing here is super important. The important one is here. This is the passenger function. And when a thread is created that represents the passenger thread will be running this function. Okay, so you can imagine this is like the lambda that you're passing into these whenever you create a thread for the passengers. Right now you can see what it's doing, right? The passenger simply just goes to your station, calls wait for train, and that's it. Okay, you don't have to worry about this. This is more for the test harness to run. You don't have to worry about this line. Now load train, you can imagine that this is run by the train thread, right? There's a thread representing the train. That thread we'll call load train. So load train, the load train function that you're writing, the one in here, load train. Okay, so yeah, this is simply the lambda. It's not written as a lambda, but it's similar to the lambda from project 2, where when a thread is created, it's going to run this function. Thirdly, there's this wait for function. What the wait for function does is it simply waits for some number of seconds, and it waits to see if some variable has changed. Okay, now this syntax is a bit confusing. You'll be wondering what this atomic thing is. Don't worry about the syntax here. You never actually have to do anything with them. When you see how it's being used, you actually, it will make much more sense. So if you go down here and we look at the basic test, let's walk through this test harness to make sure that we understand what the test is doing. So we're creating a station, right? This calls the constructor of the class you're writing. There's loaded trains at 0, boarded thread at 0. Don't worry about this. And then then these print statements tell you exactly what is happening. It tells you exactly what is happening in at each line. So here the passenger is gonna arrive, and we simulate that by saying we're gonna create a thread that represents the passenger. And notice here we pass in the station and we give it the passenger like lambda function. So what this thread that is just created, what it's going to do is it's going to start running this function, the passenger function. And the first thing it does is it calls wait for train. Okay, so you can imagine what the first line does here is it creates a passenger, and that passenger immediately calls wait for train. Okay, now this detached, don't worry too much about this. This simply means have this thread run on its own. We don't, at the end of the test, we don't have to, this like parent thread doesn't have to join all of the child threads. It's not super important. Don't worry too much about this line. Next, a train has arrived. Okay, so that's this line. And then when the train arrives, we are passing in the station and the number of seats available. Okay, remember from section, this train constructor, what you pass into the train constructor is you pass in the function you want to run, as well as the parameters for that function you're running. So remember, load train had 2 parameters, so that's why we're passing 2 of these parameters. By the way, this load train is referring to this function, load train, right? You're passing in the station and the number of seats. And then, but then within this function, the thread then calls load train, which is the function that you wrote over here, load train. All right, so let's see, let's just double check to see. Yeah, so the train has been created, we detach it. And then you can now see how wait for is being used. Wait for is saying, okay, I want to wait for this variable loaded trains. The loaded trains basically is keeping track of how many trains, this loaded trains variable is updated once here, right? After your load train returns, it updates this variable. So what that means is this line is basically saying, wait for 100 milliseconds and check whether or not this train has been loaded or has departed, right? Your load train function that you wrote needs to finish almost immediately. Okay, and why is that? Well, if a train comes, this is this one. Yeah, here we go. Wait for a train, wait for 100 milliseconds. If a train comes, but its capacity is 0, then it should immediately be done, right? The passenger doesn't get to board. There's no space. So then this train should just finish immediately. It should not block at all. Yeah, so if it returns immediately, then you get this message, which is right. If it doesn't return immediately, then it returns it. There's a return statement here. So your test harness will then just stop. It won't continue running. It would just stop. Okay. So yeah, if you notice, oh, why is it sometimes that all the lines are printing, sometimes only a few lines are printing? It's because when there's an error, it just immediately returns. So the test case just immediately stops. Cool. Now let's just go through another example. Here, 3 trains arrive. So we create a thread, we pass in representing the train, and it has 3 seats. Sorry, not 3 trains, 3 seats. Now we try waiting for the boarding threads and see if something changed, right? And then here we can say, okay, did the threads actually start? Did the passenger threads actually start boarding? If they did, then you print this message, which means that's right. And then if it didn't, then you return the error message. Okay, now, so notice this passenger has started boarding, but it hasn't been seated. Okay, this is just boarding, but it's not being seated right now. And this test is just saying, okay, make sure that while this passenger is boarding, your train doesn't just leave. Okay, now another passenger arrives. We wait for, double check that the passenger does start boarding, right? If the train is there and one person has started boarding, then if one passenger is boarding, and then another passenger comes, they get to the station, you're like, oh, there's a train already there. I'm gonna start boarding as well. So they should immediately start boarding. Okay, train should not leave. Now, what happens is then we're gonna say, okay, the first passenger finishes boarding, and then we call the seated function. This is the seated function that you're writing. Okay, notice that your train thread nor your passenger thread, neither of those threads are calling seated. It's the test harness that calls seated. Okay, this function should not block at all. It should just, you might want to update some variables. You might want to signal to some other thread saying, hey, someone was seated. But yeah, this should not block at all. Okay, then once one passenger has seated, remember you still have another passenger who's still boarding. So the train should not leave. And then once the second passenger is boarded, then your load train function should return. Okay, a load train function should only return after seated has been called twice, representing the 2 passengers that were boarding. Okay, and then your turn. If you're able to get to this point, then that means your implementation is great and you pass this basic test case. Okay, and as you can see here, there are test cases you can run. To run the test cases, you type make. Okay, so make makes the executable, and then you will have a thing called Caltrain test. Okay, you'll see 4 different test cases, and then Caltrain test basic. So right now we haven't implemented anything, so you can see that there's an error. This is the test harness stops immediately once you get to a single error. This is helpful because you can then you can copy paste this line and you can go in here and see, okay, where did it fail, right? This failed because when the train arrived with, well, actually, is this called multiple times? No, this is just once. Okay, yeah. So you can see that this is failing when a train arrives with seats available and we do have passengers waiting, but then the passenger didn't board. Okay, so you might, if this was your error, you might want to check, am I correctly, if my passengers are sleeping, am I correctly notifying the passengers, hey, a train has arrived, you might want to wake up and see if you can board. Okay, so there's probably some synchronization issue if you get this error. Right, so this is really nice, right? You can test your code, copy paste the error message, and figure out exactly where, in which example it failed. And then you can then go to your own code, draw out the scenario, right? This scenario that we've walked, a passenger arrives, train with no empty seats arrives, and then just think through that scenario to see, okay, what about my code is failing this scenario, right? That should help you debug. Just to show you an example of what, if you have correctly implemented this. So yeah, over spring break, I did all these projects. Show you an example of what it looks like when it's correct. Run Caltrain test. And then if you type basic, you'll see that you can see all the, like, this is like kind of like telling a story, right? You can see, okay, passenger arrives, begin waiting. You can go line by line to see whether this story makes sense, right? It's making sense. Everything's good so far. If it keeps going, that means everything's good so far until you get to the end. Oh, this test finishes completely. So you know that you passed this test case. Okay, you can try the other test cases, Caltrain test parallel. So let me briefly explain what this test case is. Okay, yeah, okay, so yeah, it froze for a sec. Let's explain what that test case is. What board in parallel does is it is saying, okay, if I have multiple, you can have many passengers, many passenger threads. So here we're creating 4 different ones. Okay, and then what's going to happen is when a train does arrive, all 3 of them should start boarding simultaneously, right? Because when the train arrives, you need to tell all of your threads, well, not all of your threads, 3 of these passengers, hey, there's a seat ready for you. You should wake up. Okay, so here you can see that that we're still waiting for 100 milliseconds. We're not giving you extra time. When that happens, all 3 of them should start simultaneously boarding. Okay, yeah, important. If you aren't respecting the fact that there's only 3 seats available, if you told all 4 of them to start boarding, then you'll get this error message, right? Cool. So here, and then 2 of them successfully boarded, but one of them hasn't boarded. So your train cannot leave, right? You have to still wait for that one last person to board. When that 3rd person does finish boarding, then your train can leave. Okay, so yeah, that's what like running in parallel means. If you might have multiple threads that are ready to go, when a train comes and multiple of them can board, you should tell all of them simultaneously, hey, start boarding. And because this is they're in different threads, they can each start boarding. They can each then run continue running their wait for a train function. All right, so you can see here another train comes, 10 empty seats. 10 empty seats, that this passenger should start boarding, and then this passenger has boarded. Remember that even though there's a bunch of unused seats, right? There's 99 seats open, but because there are no more passengers waiting, your train should still leave. Okay, so your train should leave when all of its seats are taken, or there's still open seats, but there's no more passengers waiting. Cool. Yeah, so that is that test. And then there's another test. This one's kind of fun. This one is no waiting passengers. So if your train comes and there's no passengers, right, we never create any passenger threads, then you should just arrive immediately. You should just return immediately. So that's that test. And then finally, there's this really fun test called the randomized test. Okay, so yeah, this is a common strategy for testing code. If you just want to try a bunch of cases to see if you accidentally hit something that went wrong, you can try this randomized test. I'll show you what that test does. That test just creates a bunch of random threads. Whoops. Okay, so yeah, sometimes you'll get issues like this. I saw some students got an issue with this for assignment 1, I think, because some of you started writing some fork bombs on the myth machine. To get around this issue, you can do SSH. You can just log on to some other myth machine. Let's try myth55.stanford.edu. Right, and then you can go to the code, which is CS111, old CS111, and then you can run that test again. Make random. Oops. Run. Oh, Caltrain test. Test. Oh, my bad. That's the starter code. That's not the correct code. This is the correct code. Oh yeah, and then you can see here that this test is just creating a bunch of passengers. Yeah, it just creates a bunch of, well, it creates a bunch of passengers, 1,000 passengers, and then it creates a bunch of trains. And then it's just going to check that the right number of passengers are going, and you can see here the number of passengers starts dwindling down and down. Okay, and this is all randomly generated. If you run this a couple times and it all passes, you should be pretty confident that your code is working. Okay, yeah, one thing I do want to mention, don't run Valgrind on this. You can even read in the starter code that whoever wrote this admits that this is leaking memory. So yeah, like don't run Valgrind in this problem. You should not be using, in this code, I don't think you should ever have to explicitly allocate and deallocate memory yourself. So yeah, there's no real point in testing Valgrind. Cool. All right, some strategies for testing this. So my favorite strategy, I'm not a fan of GBB, but my favorite strategy is to add print statements, right? You can add a print statement inside here. Do couts. You might need to include. And then if you do a bunch of couts here, you'll be able to print, and that will help you in addition to this story that they wrote already right here. Caltrain test. In addition to this story that you see, you can add a bunch of extra print statements in there, and that will help you to figure out, okay, is something wrong? You can try printing out the variables you're saving, right? You might want to store how many passengers you're boarding, save those variables, and that will help you figure out what is, if you forgot to change something or if you forgot to wake a thread up. Cool. All right. So we're done with one problem. That was a little longer than I expected. Let's go over the second problem quickly. Okay, second problem is a little bit more complicated. This problem is actually interesting because when I took this class, I took CS 140 2 years ago, and this was actually my midterm problem, and we had 30 minutes to do it. Okay, yeah, this assignment I'd say is significantly shorter. You will likely get a synchronization problem, probably on the midterm or on the final. And if you do, you have a limited time to do them, right? 30, 45 minutes. So, ideally, if you became really good at synchronization problems and this is the day before the midterm, you should be able to finish this assignment within 1 hour, 1.5 hours. Okay, if you are midterm ready. Obviously, this is your first time doing mutexes and condition variables, so it might take a bit longer, but yeah, it's definitely shorter than the first two projects. Okay, so let's talk about this problem. Yeah, this was the midterm problem I got. So you are hired by the Stanford Greek houses. You're going to manage parties, and here's how this party is going to work. There is a single function called meet. Okay, and how does this meet function work? You have a bunch of threads. Okay, all of the threads represent students. Okay, so you have a bunch of threads. Each thread is a student, and when they enter the party and they want to meet someone, they just simply call this meet function. They pass in their own name, they pass in their own zodiac sign, and then they pass in a zodiac sign of someone else they want to meet in the party. Okay, maybe this is a zodiac theme party or something. Yeah, so you pass in your own sign, you pass in someone else's sign. Okay, and then what this meet function should do is it should just block, right? You write your name on their, and then there's their list, and then you just wait. This is kind of a weird party. You just stand there and you just wait. You do nothing. Oh, actually, you don't even wait. You sleep. You block, the thread blocks, you sleep, and you just wait there until someone else, another guest, comes in and they call meet. Okay, now here's the important part. Even if they call meet, it's not true that you will be paired with them, right? We're trying to pair guests, but it's not true that you'll be paired with them. To be paired with someone, you requested your own, you said what your own zodiac sign is. You also said who you want the other person's zodiac sign is. Okay, on the other side, when they call meet, they're also going to put their zodiac sign, and they're also going to put what they want the other person's zodiac sign to be. Okay, so for there to be a perfect match, your request of who the other's zodiac sign is has to match what their zodiac sign is, and what their zodiac sign has to be matched with what your zodiac sign is. Okay, so basically, you have what you want, they need to be that sign, and what they want, you need to be that sign. Okay, so yeah, I'll do an example of that later, but yeah, it has to perfectly match. You have to satisfy their preference, and then they have to satisfy your preference. Cool, yeah, it's just like real life. And then this function actually returns something, right? Unlike any of the previous functions, this function returns a string, and this string is the name of whoever you are matched with. Anything else interesting here? Well, the zodiac signs are integers within this range, so it's some fixed number. And then you have, let's see, parties independently. Okay, so yeah, it's possible multiple parties are created. So if multiple parties are created, those should not interact at all. So what that means is, I know from last week's project, you all learned a lot about static variables, right? Static variables are variables that are shared among all instances of a class. Well, here, you don't really want to share anything between multiple parties, right? If you're in one party, you're not going to get paired with someone else in some other party. So yeah, for this problem, and also for the Caltrain problem, you should not use any static variables because each party you create should be independent. Okay, and static variables are only for cases where you want a variable that is shared among all instances of your class. Okay, like for your thread class, the thread queue should be shared among all threads. Okay, cool. Yeah, there's this last requirement. Guests must be matched in order of execution. So if two threads come and, if two guests come, one, then the other. And then when it's time to match, if both of them can be matched to someone new who just came, then you have to match the first thread. Cool, let's just quickly look at the starter code. That's the party. Okay, so here you can see that this function is it's pretty similar to the Caltrain problem. Your class declaration is up here, and the implementation is down here. There's just fewer methods. There's a constant here called num signs, and then you have this one function that you're going to write called meet. Okay, and it passes in the name, or your own name, your sign, the other sign, and then the other person's name. It should be returned. Just like the Caltrain problem, we've declared a mutex for you, and you should not add any other mutexes. You should just keep this mutex. This mutex should protect all the member variables inside of your class. And whenever you need to modify them, just call lock on these, or not call lock. You should use the lock guard, not lock guard, the unique lock class that you are introduced to in section 3. Okay, you might want to look at section 3. There is a unique lock. That's how you lock these mutexes. Just as like before, you have this initializer list. Definitely use the initializer list. Don't go inside of your class and initialize your members one at a time. And yeah, that's mostly it for this function. One thing I want to suggest is that you can imagine that there are a lot of different possible ways to pair these guests, right? Like imagine that you are sign, let's say I am like, my zodiac sign is 1, and then I want to be matched with someone whose zodiac sign is 2, right? And then someone else who comes in who wants to be matched with me has to have zodiac sign 2, and they're looking for someone with zodiac sign 1, my zodiac sign. That's the only way we can be matched. Okay, if we have a lot of different guests and they're all looking for different things, then you have to remember all of these threads, right? You have to remember all of these threads, and you need some way to efficiently check if there is someone who you can be matched with. Okay, let's say I came to the party, I'm sign 1 and I'm looking for sign 2. You need to efficiently be able to check, is there someone who is waiting right now who is sign 2 and is looking for someone with sign 1? Okay, you need to efficiently look that up. You can't just, randomly store everyone in a vector and then, do a linear scan over it to find who you can be matched with. That's too inefficient. So you'll need some data structure to store the, like every single person's name, as well as what their sign is and what they're looking for. Okay, so you should probably think over what data structures would make sense here. There are a couple possibilities. I'm not going to tell you which one to use. There are a couple you should try thinking of, but I will say that like John's solutions uses one data structure. When I did the problem, I used some other data structure. There are multiple possibilities. So yeah, you can take your pick. Think through all the data structures you learned in 106B and 107. Think about which one's most efficient for this problem. Just as a tip, I know some of you, complained that, for the C++ queue, how like you were a little surprised that pop doesn't return the element. It's not like the Stanford C++ 106B library. It actually, you have to call front and then pop. Yeah, so for instances like this, what you want to do is you want to go to the reference, CPP reference. Okay, a lot of programming is about just looking things up. I certainly don't remember any of the, I certainly don't remember details about the C++ library. So what you should do is you should go here, and just to give you an idea of where the data structures are, you can go to, where's the data structures? Containers here, containers. Okay, so containers, this is all of the data structures, and you can look through all these data structures to figure out how to use them. For example, you might want to consider using a deck, right? Some of you use a deck for assignment 2. You might also use like a map. Let's say map. Okay. If you see a map here, you can see all the different ways to use a map. There's the different operators. There is the insert function, the erase function, the find, the count function. Yeah, so here are essentially just different data structures you can use, and you can figure out how to use them by looking at the examples. You can also just Google like examples of how to use the C++ map. Okay. Yeah, so yeah, be sure to go in and check out these data structures. Throughout the class, you will have to look at some C++ documentation yourself to figure out how to use it. So just check this out. In addition, all the other relevant C++, like how do you use like a unique pointer, as you saw in assignment 2? How do you use a, what was that thing? It was called a condition variable. How do you use a condition variable? Here is the condition variable documentation, as well as examples and all the methods for them. Yeah, just go on the documentation, and that should be, you should be able to find information. Cool. All right. So yeah, we're almost done. I just want to go over a couple hints about this problem. So I've given you a hint. You want to figure out some data structure to efficiently find if there is someone who can be matched with. Now, if there's no one that you can be matched with, then you would need to wait, right? Then you would need to add yourself to your data structure and sleep. A couple other questions to wake. Well, who is waiting on who, right? Like when if you go into the party and you are not matched, you go to sleep. Then when someone else comes in and they realize that they can be matched with you, they should be the one who tells you to wake up and be matched with each other. Okay, so you want to think about how many condition variables you want and who is responsible for waking up the thread that went to sleep. Okay, in addition, you might wonder, why don't we just use a single condition variable here? And then every time someone comes in and can be matched, you just use that single condition variable. Well, when that happens, right, if everyone is waiting on one single condition variable, and every time a new person comes in and gets matched, that they have to wake everyone up, right? And that's not super efficient. So instead of waking everyone up, you only want to wake up the person that you are matched with. Okay, so think about how you're going to set up your condition variable that way, so you don't wake everyone up. You only wake the threads that you want to continue with. Cool. Other hints. Another hint I want to give is that you might end up dealing with a lot of variables here. You might have variables for each guest, right? Each guest, you might need to store their names. You might need to store their zodiac signs. You might need to store who they're matched with. There's a lot of variables here, so I highly recommend that you create a separate struct, right, or a class or a struct. Create a type, a class that you can encapsulate all of the variables for a single person. Okay, so don't just have all of their variables lying around in this party class. Encapsulate them in their own little class, and then you can store like data structures of these variables instead. Another thing to consider, right? When you are matched with someone, you have to get their names, and then the other person has to get your name. How do you ensure, like, how do you pass your name to the other thread? Okay, that's something to think about. Remember that both threads have access to this party, so you'll need to figure out a way to put your name somewhere so that the other thread can access your name. Okay, yeah, that's mostly it for all of the hints I want to give. Let's quickly walk through the starter code, or not the starter code, the test harness. And test harness is fairly similar, right? There is, let's just look at the matches. You can see here a couple test cases, 2 guests match. You create a party, create match A, match B, and then you have these print statements, right? Guest A arrives with sign 0, the other person is sign 5. This is like storytelling. So a guest arrives, here's their sign, here's who they're looking for. And then you create a thread that runs the function. It's just like the Caltrain. Instead here, it's guests. They're assigned 0, they're looking for sign 5. Then another guest arrives, they have sign 5, and they're looking for sign 0. Oh, they're a perfect match. So then this function waits a little bit and checks that guest A and guest B, they are done. Their threads have returned from the match function. And if you check their matches, if you check the return values of their matches, guest A wants guest B, and guest B gets guest A. So they have the names of the person they're matched with. Awesome. Cool. Yeah. And then there's other test cases. This test case is saying if you have multiple people who come in with the same zodiac sign and they're looking for the same zodiac sign of the other person, so you have 3 copies of the same people, then when you have a guest who comes in who do nothing. Oh, but then when guest D comes in, right, and they have sign 3 and looking for sign 1, then the person they should be matched with is the first person that comes, is the first person who came with sign 1, 3. So person guest D should be matched with guest A. So yeah, A should be matched with D, D should be matched with A. B and C are still waiting. They're still waiting for someone to come. So they don't have a name yet. Okay, yeah, and then this is essentially just the same process. If E comes, then because B came before C, E should be matched with B, and C is still waiting. This test is testing to double check that your signs are correct. So remember, if your sign is 1, 3, then the other person you're matched with has to be 3, 1. Okay, so here, A, B, C all have different signs that are not compatible, so no one should be matched. Finally, when someone comes in that is compatible, then you are able to match them. Yeah, so the key thing is just remember, if your sign is A and their sign is B, then, sorry, if your sign is A and you're looking for someone with sign B, then the other person has to have sign B and I'm looking for someone with sign A. Yeah, then there's just this edge case. If the person you're looking for has the same sign as you, then 2, 2 should be matched with someone from 2, 2. All right, yeah, that's it for the starter code. All right, yeah, and then testing strategy is very similar to Caltrain. Add some print statements in here. If you run the Caltrain test, it's not the Caltrain test, the party test. Use it in the exact same way. Sign. Yeah, then you can actually get a printout of like a story of what happened, and then you can just check if all the matches are correct. If you get an error, copy paste the error and look into the starter code to see what situation you are failing. If you add some print statements, you will see them interweaved between these lines of code. So then you can check if one of your variables is not behaving how you expect them to. All right. So yeah, we are mostly done with our walkthrough. This walkthrough was a little longer than I expected. I might try to keep them shorter in the future, but let me just check. Is there anything I want to mention? I mentioned don't use static. I mentioned the starter code and the examples. Yeah, so I think we're done. Cool. So feel free to comment on the ed post if you have any questions. And yeah, if you have any feedback about how you want these walkthrough videos to be, let me know. Otherwise, good luck on this assignment. I promise this assignment will take much less time than projects 1 or 2. And yeah, good luck with the assignment and have a good rest of your weekend. Bye.